We will see how we can solve equations by elimination. In order to solve equations, you can always use this method. Every time it will work, or you can use the other methods, but this is one of the easier method. Now imagine you have been given two equations. Whenever we are solving, what does it mean? Now, if we say graph these both, it would be something like this. Now, if you get this into point slope form, you'll get a negative slope. The line goes downwards. Over here, you will have a positive slope. The line goes upwards. So this is just a rough two lines. And now there'll be a point where it will touch, right? That is the solution point. That is what we need to solve. What does it mean by solve by elimination? We are solving for x and the y values, the x and y coordinates of the point where these two lines touch. So if in case these two lines wouldn't have touched, they were parallel, then you would never get any answer. It will be error. So they would never touch each other. But in this case, let's solve them and let's check whether they will touch or no. But generally, whenever they give you this problem, you need to follow the method which we'll do now, and you will get an x value and a y value, and that will be the solution. Now, here there are two different lines, right? Now, how can we solve this? Now, look over here. Since you're finding the point where it intersects, that means over there they both are equal, right? So you need to equate them. But not just directly equate them, you need to understand if you're doing any operations over here, do the same over here. And try to solve them and reduce them and find the x and y values. Now you can see there is 4x plus 3y equals 17, 5x minus y equals 7. So now over here there is change in sign. So what happens when you are plus 1 and minus 1? When you add them, they become 0. It's not about getting 0. It's just that you're eliminating this term altogether, right? Now, this is not a good example. Let me take 1x and minus 1x. Now you can see this entire thing becomes 0. The variable is gone. The same thing we are going to do over here. If you add 3y and minus 3y, then this term would eliminate, right? So let's do that. But over here we don't have 3y, we just have y. Now we need to get 3y over here. So you just can't multiply 3y over here. You need to multiply in the entire equation. You need to balance the equation out. Now if you have, say, 3x plus 3y equals 3, you can divide this throughout by 3. The answer is x plus y equals 1. These both are the same equation. That's the same line. If you graph them in the graphing calculator Desmos, you would get the same line for both of them. So same way, now you just don't multiply 3 over here, you need to multiply the entire equation. So this equation remains because we have 3y, it's fine. We are multiplying over here. 3 times 5 is 15x minus 3y equals 21. And now you can add them up together. Add each sides, this term cancels off, it becomes 0, but don't forget to add the other terms as well over here and over here. So it would be 4 plus 15, 19x plus 0 equals 38. Now, some of you might be wondering, okay, why don't we divide this by 3 over here and then it would be y and y, this would cancel. Yes, absolutely, you can do it. But it would just be a bit more complicated, don't you agree? Because it would be 4 by 3. This would be, yes, only y, and this will be 17 by 3. So to avoid complications, we just multiply, which is much easier in this case. Now then, we have got simplified equation. Now there is no y term, so you can easily solve for x. The main intention was to eliminate one of the variable, x or y, get in terms of single variable and solve that variable. So now we solve 19x equals 38. That is 2. X is 2. So we found the x value. So in these two lines, wherever it touches the x, this point, sorry, the x value is 2. What about the y value? We know these both must be at equal, at that particular point where it touches. So you can substitute this x in any one of these equations. It doesn't matter because both of those equations will be at this particular point. When x is equal to 2, the y value must be same, otherwise they won't intersect at that point, isn't it? So you can substitute x at any one of this equation, you will get the same answer. So anyone that is over here, this one is taken y because this is simpler, right? Y is small, just simpler compared to this. So we substitute x as 2 and it'll be 10 minus y equals 7, and take this y to the other side because you're not solving for negative y, you need x and y that is positive. So take y to the other side and bring 7 to this other side, and now solve it, you will get 3. So the answer, the solution for this particular equation is 2 and 3. Now, before you end this, I would like to ask you all, try substituting x as 2 over here and solve, and check whether you will get it as 3 or no. You must get 3. If you get anything else, then there must be some error. So do try it. And you can even try the other way around. You can solve this x first and find y first, and then you can find, other thing. You can do a check, substitute this y over here and solve for x. It should be the same. So these are the solution region, and this is the method of elimination. These are the answers.